Welcome back everyone. In this video we're going to discuss about triangles. Here we'll be discussing two theorems and we'll be looking into some numericals based on those two theorems. So without any further ado, let's get started. Let us prove the first theorem. The internal bisector of an angle of a triangle divides the opposite side internally in the ratio of the sides containing the angle. What do you mean by that? If you have a triangle, let's say ABC, and if AD is the bisector of angle A, then you will have this side to be divided in the ratio of the sides containing the angle, that is this is to this, that is BD by DC is equal to AB by AC. Given triangle ABC in which AD, the internal bisector of angle A, meets BC in D, to prove that BD by DC is equal to AB by AC, we'll have to construct few things. CE parallel to DA, this CE parallel to DA meeting BA produce. So if you produce this and you draw this parallel, wherever they meet, that point is your E. Proof is very simple. Since CE is parallel to DA, AC cuts them, right? Therefore, angle 2 equals angle 3. Angle 2 equals angle 3 because they are interior alternate angles. Angle 1 equals angle 4, corresponding angles, but angle 1 is equal to angle 2 because this is the bisector of angle A. Bisector means it divides the angle into two equal parts. So if you combine these three, see, angle 1 is equal to angle 2, but angle 1 is equal to angle 4. That means angle 2 is equal to angle 4. Okay, then from here we have angle 2 is equal to angle 3. So that means this angle is equal to angle 3. That means angle 3 is equal to angle 4. Therefore, AE equals to AC. So angle 3, this is angle 3, opposite side is this. Angle 4, opposite side is this. So we have AE equals to AC. Now in triangle BCE, so BCE, this big triangle, DA is parallel to CE. Therefore, BD by DC is equal to BA by AE by Thales theorem, if you remember. Okay, this can be treated as the line and this whole thing can be treated as a triangle. This implies BD by DC is equal to AB by AC. Hence, BD by DC is equal to AB by AC. So from here we have this and this is equal. So definitely this and this also will be equal, and hence it is proved. Let us now prove the second theorem, that is the external bisector of an angle of a triangle divides the opposite side externally in the ratio of the sides containing the angle. So if you see, it's very similar to the previous theorem. Given triangle ABC, AD is the bisector of exterior angle A. So this is your angle A, okay, this is your angle A, and this line AD is the external bisector. If this is your angle, then the external bisector will lie outside the angle, intersecting BC produced in D. Okay, this BC is produced and it will meet at D. What do you have to prove? That BD by CD, that is this point, so BD by CD will divide it in the ratio of the sides containing the angle. So sides containing the angle is AB by AC. Construction: draw CE parallel to DA. CE parallel to DA intersecting at AB in E. Proof: since CE is parallel to DA, AC intersects them. Therefore, angle 1 is equal to angle 3. Why? Alternate angles. Angle 1 is equal to angle 3 because of alternate angle. Also, CE parallel to DA and BP intersects them. So angle 2 equals to angle 4, corresponding angles, but angle 1 equals to angle 2. So from all this equation we have angle 3 equals to angle 4. Then definitely in triangle ACE, AE is equal to AC because sides opposite to equal angles are equal. This is angle 4, so opposite side is this one. This is angle 3, opposite side is this one. Since these two angles are equal, these two sides also definitely are equal. In triangle BAD, EC parallel to AD, EC parallel to AD. So by Thales theorem, we have BD by CD is equal to AB by AE. But from here we know that AE is AC, so we can substitute and we simply get BD by CD is equal to AB by AC. Let us see the first question shown on the screen. In triangle ABC, AD is the bisector of angle A intersecting the sides BC at D. If AB is 5, AC is 4.2 and DC is equal to 2.1 centimeter, find BD. So number 1, given AD is the bisector of angle A, AB is 5, AC is 4.2 and DC is equal to 2.1. In triangle ABC, using the first theorem, we know that BD by DC is equal to AB by AC. So if you substitute and cross multiply, you'll get BD is equal to this, which is nothing but 2.5 centimeter. Let us see one more question. Given AD bisects angle A, AB is 10, AC is 6, BC is 12. So we know that in triangle BD by DC, that is this by this, is equal to this by this, the side containing the angles. So this. Then from here we can say that BD is equal to DC into this. Since we don't have DC, we can't substitute. But we know that BD is nothing but BC minus DC. So we can substitute that. Now BC it is given to be 12. So if you substitute this, if you substitute the value, this will be an equation basically based on a variable that is DC. So if you simplify, you will get DC is equal to 4.5. From equation 1 we have BD is equal to 4.5 into 10 by 6, which is nothing but 7.5. This is equation 1. In figure, check whether AD is the bisector of angle A in ABC in the following cases. So the first case is AB is 5, AC is 10, BD is 1.5 and DC is 3.5. So we'll just write given. This is what it is given. Then we'll find AB by AC, that is side containing the angle AB by AC, which is half, which is 0.5, and we will check the base, which is BD by DC. So if you divide, it will be 0.3, which is 0.1 by 3, which is 0.33333. So obviously these two are not equal. Clearly AB by AC is not equal to BD by DC, hence AD does not bisect angle A. In the figure, ABC is such that BD by DC is equal to AB by AC, angle B is equal to 70, angle C is equal to 50. Find angle BAD. Okay, so this is your triangle. Here this is the bisector, that means these two angles are definitely equal. ABD is 70 and ACD is 50. So how do you do that? Given that this is true, now if you see, this looks like the first theorem, okay, where this by this is equal to the side containing the angle, okay, ratio, that is AD is the bisector of angle A and angle B is 70, angle C is 50. So in triangle ABC, this, that is sum of all the angles of a triangle, has to be 180. Angle sum property. This implies angle BAC is equal to 180 minus 120, which is 60. So we have that angle BAC is 60. Since this is the bisector, that means this has to be half. So angle BAD is half of angle BAC, that is BAC by 2, which is nothing but 60 by 2, which is 30. Okay. In the figure, AE is the bisector of exterior angle CAD intersecting BC produced in D. If AB is equal to 10 cm, AC 6, BC 12, find CE. So basically this is your figure where this is your angle and it is bisected externally, something like this. So AE is the bisector of this angle A externally, and these are the values that is already given. Okay, so this looks like the second theorem that we discussed. So given AE bisects angle CAD and these are the values that is given. In triangle BAE, by second theorem we have AB by AC, AB by AC, that is the side containing the angle, is equal to BE by CE, BE by CE. So substituting the values, we do not know what is BE, but we know what is BC, so we'll substitute that. So BC plus CE will be BE. So if you substitute this, we know the value of BC. Substituting, now we can cross multiply and this will be an equation based on CE. So if you solve, you get CE is equal to this, which is nothing but 18 centimeter. So it's very easy. You'll just have to remember the theorem 1 and theorem 2 and also their difference. Please practice as many questions as possible and drop your queries in the comment box. Thank you for watching everyone. I hope to see you in my next video. Take care everyone.